Okay, so this is an introduction to using databases in R, but with Tidyverse tools. So I'm Vebash. So who am I? I'm a bit of a data nerd. I'm also an organizer of R Ladies in Johannesburg. I was one of the founders of R Ladies in Johannesburg. I'm a mom, and that last picture is of me in far out places because that's what happens when you're a mom. You travel to some far out places. So who are you? So you've got data in a database. You know enough of the tidyverse, and you want to flex that skill and also lighten your cognitive load. Because we all know that switching between R and SQL, even though the tidyverse is quite geared to kind of mimic SQL, it makes it still hard on your cognitive load to write SQL one time and write R code tidyverse one time. And I'm a prime example of this because if I write SQL query, I often put the double equals when I'm trying to filter out values because of that switching of context. Okay, so the SQL query format, it's very different from its execution format. And I'm sure most of you know that. And it's also why the tidyverse feels more natural for me. And we'll talk about that a little more later. But this is the query format, right? It's select from, join with some other table where some conditions hold, where we're grouping by certain criteria, having another criteria, we order by and we limit, right? But the execution is it grabs the information from the table first. So it brings in the table, then it does any joins it needs to, then it does the filtering, then the group by and the having, which are very similar. Those are like, so the group by and having kind of function in the same way. Then it selects any of the variables, also getting the distinct rows, then ordering by, and then limiting your query. I see someone has their hand raised.
Oh, Emmanuel is saying participants can't speak. Okay. And if Laura, type your question.
They're asking for the slides. Will someone just pop that in the link in the chat for the participants, please? There should be both the slides as well as the GitHub link.
Thank you. We are seeing them.
Cool. Perfect. So then let's just do a quick tidyverse knowledge check, right? Have a look at this piece of code and then think about it for a minute and then make a choice on the next tab. And maybe just pop it in the chat. What do you think that this piece of code is doing? Oh, it seems that the chat is disabled. Okay, but then, okay, let's just talk through it, right? So this is just to kind of gauge what your tidyverse knowledge is, because the rest of the workshop kind of assumes you know a little bit about tidyverse, right? So here we're working with the Palmer Penguins data set. And what we're doing is just selecting out of it 3 of the columns, the species, the sex, and the flipper length, right? Then we drop NA. So drop NA here will drop any NA values in any of these columns so that we get like a full data set. Then we group by the species as well as the sex. And we are summarizing that value by getting the mean flipper length. So after options, it's actually number 3. So it returns only the average flipper length of each species. It doesn't because it's looking at both species as well as sex. It returns the entire data set with the average flipper length of the species tagged on. That would only happen if you're using a mutate. So if I was here, instead of the summarize, if I used a mutate and then I ungrouped it, it would return me everything with that tagged on. But again, it was doing it a group by on species as well as sex. So the third answer is actually the correct one. So it gives you the average flipper length by species and sex, and it only has full values. And this one I just threw in because it's quite nice for people like us who have to follow the Queen's English. We use summarize with an S and not with a Z. But Hadley, luckily, who comes from New Zealand, also had the same. So Tidyverse lets us have both, the best of both worlds. So I can have my color with the U in it as well. So this is the output of that little bit of Tidyverse. So it groups it by the species and the sex, and it gives you your average flipper length. Okay, I'm just keeping an eye on the chat. If anyone has any problems, if I'm going too fast or too slow for you, maybe if you can just let me know. Okay, so here, the Tidyverse equivalent or execution, right? From the execution, now that we know that it happens in this order, what are the Tidyverse verbs that kind of tie with that, that's equivalent to that? So here's why I say that I think the Tidyverse kind of follows, it's more natural to kind of write it that way, the same way that the execution is happening. The from, it's usually the table name or the data frame, which we pipe into some functions further, right? The join, this one is any one of inner join, left join, right join, etc. The where is the filtering, where you filter by some condition, is the equivalent of the where condition. Group by, that one is just the group by function. Having functions similarly to a filter after a group by. Select, that's just select in dplyr. But here we have more options as well. We can also mutate. Mutate is also like a select, but it's almost like a select as. The count function, that one will be select count in the SQL execution format. And the summarize is all your aggregation functions. So where I have a summarize in Tidyverse, I would say select average flipper length as some column and from the Palmer penguins. Distinct now takes all of your data and then it says across all these rows, I want some kind of distinct characteristic. So we can run distinct by itself with nothing in the brackets. That will get you distinct for across all columns, or you may want just distinct in specific columns. Then you can also arrange that by some column order. And here in the SQL world, we say order by some column descending, for example. In the arrange function, we'll have the arrange, then we have to have descending as another function and put our column in it. Okay, so what are we going to cover today? We're going to cover connecting to a SQL database, using dplyr verbs to explore and interact with data in that database. We want to also transfer the computation to a SQL engine. So a lot of times you don't really want to bring in a lot of data into your R Studio session, right? The benefits of working with SQL directly on the database is that the computation is handled by the SQL engine instead of it being handled within R itself. And we'll go through that later on. So I'll show you how it works. We can run the SQL code directly on the database. And we'll also figure out the equivalent dplyr code from a SQL query. I hope we can get through all of this. But if we don't, it's in the course material on GitHub. So you can always follow it after the fact as well. Okay, so connecting to a database. We need a couple of core packages and there's a certain way that we connect to the database. We need to install the DBI package. So what the DBI package does is it kind of makes the front-end API that we would work with as a user common, and it leverages the other drivers and packages behind the scenes to talk to that particular dialect of SQL. So let's say I've got DBI as a package, but I want to talk to a SQLite database. I will then use the SQLite package, which contains the drivers for SQLite, and it will then talk to a SQLite database using dplyr code, which gets converted to that SQLite kind of dialect. Same thing for a MySQL database. What the DBI package is, I still function with my database in the same way. I don't know what's behind. It's almost like it obfuscates what's behind the scenes. So I will connect to a SQL database via DBI. So I create a connection. It then talks to through the SQL package, or it's the R MariaDB package, to the actual SQL database. So it's similar for a lot of the other ones, right? Yeah, so it's just like a database interface that talks to different database management systems behind the scenes. Some of them are not in packages. So then we need the odbc package. So the odbc package helps us because it's a consistent way to talk to a lot of database management systems. And then you can talk to a lot of the different dialects of SQL without necessarily having a database package within R. The dplyr package is just a dplyr backend for the databases. So you write normal dplyr code and it converts it to the dialect that is needed in the backend. Okay, so let's look at an example for SQLite, right? So SQLite has a package that we can install. So here, we won't talk to it via an odbc driver. We rather talk to it via the package. So we will first install this package, and then we use it to make a connection to that database via DBI. So here, DBI is doing the heavy lifting for us. We make a connection via this RSQLite database. Here, it's just creating an in-memory database. But usually, you would connect to, let's say this was, you'll see another one in here, but let's say this was an R MariaDB database, right? We would then connect to that R MariaDB database, and you'd give it a name here, or a connection string to connect to that particular database. Okay, here we can just list what tables are there. At the moment, because we've made no connections, there's nothing. We just created a connection within memory, but we haven't yet got any tables at that connection. There's another DBI compliant package, which is, for example, R Postgres. So here, it's similar to what we've had in the previous one. You can again see we're using DB Connect, right? So we, as the users, have it's a standard front-end API that we use to connect to the database. But here now we have to give it a few more things like the database name, where is it hosted, what's your username, what's your password, what port are you actually containing, what port are you connecting on. Okay, so there's a whole bunch of packages that are DBI compliant, like R Postgres, R MariaDB. I think there's a Redshift one. So there's quite a few different DBI compliant packages. But if you don't have a package, what you have to do then is use an odbc driver. So here, again, we use DB Connect. So the way that we're connecting to the database doesn't change, but we're also including this odbc connection. So a driver is, you can think of it as like you'd have to put install a printer driver to be able to connect your computer to print out the printer. Similar way, the driver, all it does is it says, this is a way for me to connect to that MySQL database or to that SQL Server database. That's all that a driver is. Similar to this DBI compliant package, you also have to give it some extra parameters to connect to your database. I'm just having a look that the chat is still fine. Cool. Okay, so once we've connected now, we're going to use the MySQL, the SQLite database, sorry. We've connected via this way. So we made a connection to this RSQLite in memory. Remember, there was no database tables at that connection. So some of the things we can do now that we've got it, we can write data into that database. So we can write, for example, the empty cars database or data into that database. We can list tables at that connection. So it'll tell us, oh, look, I've created now an empty cars table at that connection. We can also then further list the fields within a particular table. And then the cool part is we can use dplyr pipelines. So here, the only thing that changes from a normal dplyr pipe or like process is here we would usually have the name of our table, right? But in this case, we have to say, look, use this connection con that I've created previously and go reach into the empty cars table. And that's what I want you to do your processing on. And then it uses normal dplyr code to get you the rest of it. So it first selects the cylinder and then it gets you the distinct cylinders. Okay, here you can see this results in this like lazy query with these question marks. So what that does is it runs that on the database, but it doesn't bring you back everything. In this case, because it was so small, empty cars is a small data set, it would bring you back all of the cylinders, right? But in a normal big query, you don't actually want that. You just kind of want it, you can think of it like a glimpse in R. I don't know if lots of you have used glimpse before, but glimpse almost gives you like a snippet of your data. This does a similar thing. It gives you like a snippet of that table within the database. So it's saying reach into the database, get me that data, do this processing on it, and then show me that data. Okay, so you can select subset of data. You can do your analysis of data directly on the database. So all of this, none of this information is sitting in R as yet. It's all sitting outside of R, and it's just kind of querying it there and showing you the results within your R console or your R RMD file. Yeah, so we can do a lot with it via this way. You can do joining of tables. So here, one of the things to note is you would usually in a normal, let's say you had read 2 different tables from CSV files. What you would do is you would join table 1 and table 2, but just giving its name. So the data frame name. So you'd say table 1, you'd pipe it into a left join with table 2 by some columns, right? In this case, you would need to join with another connected table on that database. So here you're saying reach into the connection and get me table number 1, then left join with this same through that connection, go get me table 2, and I want to join it via these means. So table name 1, column 1 with table name 2, name 1. And then table name 1 dot column n with table name 2 dot name n. Okay, so then we can also have a look at what the SQL is behind the scenes. So you can see, hey, look, now we've got this, we have an ability to work with it within R, right? But now what's the actual query behind the scene? And that's quite cool. So you can also, if you're more familiar with Tidyverse, you can use it as a means to actually learn a bit of SQL if that's not your strong suit. Like here, it shows you we've counted the cylinders, and then the show query is giving you the actual SQL query for this. So you can run this SQL code directly on your database. You can also create a SQL connection. So if you're more familiar with SQL, you can create the connection via DBI, and then you can have a code block. So just excuse this extra brackets. I don't know how to get rid of it, because if I just take it out, it doesn't show you the string, and this is the important part, right? So what I want to say here is that the connection here, it's saying, I want a SQL query block or SQL code block. I want to use this connection. So using that, please reach into this connection and go and select the distinct cylinder from empty cars. So this allows you to write SQL on that database as well. Okay, so all of this that we've done so far has been just looking at the data, getting like a glimpse into your data, right? Even though you've processed it, you're still getting a glimpse of that processed information back. But at some point, you may actually want to utilize this data. You want to actually graph on it, or you want to do something, and you can't do it just by like if I stop here and we have many cylinders, right? Or a lot of information, that's not going to work very well because it's only giving you a glimpse of the data. So once you're ready to work with it in R, let's say you want to plot a ggplot on it. Now you bring it into R by using this collect function. And what that does is now it saves this entire query's information into my DB empty cars. Finally, when you're done, it's good practice to disconnect from your connection. Okay, so let's take stock, right? That was a lot of information in one session. And I know you guys can't put it on the chat or discuss this amongst yourselves. But now, given what I've told you previously, right? We need to like unscramble this this list of information in order to make a connection, right? I want to reach into some connection, and it looks like it's an RSQLite connection, and I want to eventually get the data for band members. So this was supposed to be more interactive. Now I feel like I'm talking to myself. maybe one of the panelists. I think that would be nice. From the panelists, is there anyone who would maybe take a stab at it?
I'll have a go.
Cool.
So obviously we start with library DBI, is that correct?
Perfect.
It looks like we have to define the connections. So con is assigned by db connect R SQLite memory. Okay, so that is 2. Okay. DB list fields, band members, number 3. I think, is that right?
So here we'd first have to write the table in.
All right. Okay, so write the table. So yeah. Oh, I see. Yes, yes. Sorry, that's correct. Yeah, and then DB list fields.
Cool.
And let's see. Sorry, I've lost track now. So table connection, band members. That would probably be the last one.
Yes, you could do, so this one, arguably you could do any one of them in either order.
Okay,
so 3
yeah.
or 6 could go anywhere.
Yeah, yeah.
Cool,
Okay.
Thanks, Kevin. Yeah, so that's, this is the order, and then finally to disconnect. So here's the result of it on the side. All of this code is copy and pastable. So as long as you have these libraries installed, you can run this yourself. Okay, so Alison Hill put together some data from like the Great British Bake Off, right? And you'll be able to click on the link and see it here. But I converted it to a SQL database that we can practice on.
The last slide, may you explain each point?
Oh, yes, 100%. Okay, cool. So first, in order to reach into this database and make a connection, we need the DBI package. So the DBI package, as we said, is like a front-end API for connecting to any dialect of SQL database behind the scenes, either via a DBI compliant package like RSQLite is, or via a driver that's an odbc driver, right? So the first thing we do is connect to that or install, load that library. Then we make a connection via the RSQLite package, but we're making an in-memory connection. So all this is saying is, look, I don't have a database as yet. I'm actually going to create it kind of on the fly, right? But I want a database that I can practice my dbplyr on, as well as my SQL on, for example. So I make an in-memory database. I then, to that connection, I write this dplyr band members data. So you'll see dplyr comes with a bunch of like data sets. So this is one of them. And all I'm doing is writing it into this table name at this connection. Then the DB list fields just tells you, okay, now I've got this table written, right? So reach into this connection and tell me what are the field names in my band members table. So here you can see name and band came back, right? This one says, it's like you can think of this one as a select star from band members, but it does a lazy select. So here it's giving you back something, but it's giving you back a snippet of the data. So it's saying, reach into this connection and give me everything that's in band members. But the DBI package is limiting the amount of information that is shown in your R Studio console or your R Studio RMD file. It's saying, I'm not gonna flood you. I'm gonna make a call and I'm gonna give you back a little snippet of the data. Once we have this snippet, we can disconnect from our connection because we are assuming we do more than this, right? This is just a small example, but we'd bring in the data, we'd probably process it, we'd save what information we need, and then we disconnect from that connection because we don't need to keep it alive anymore. I hope that helps.
Yeah, a lot. Thank you.
Cool. Okay, so this one is just another example, right? So I converted the Great British Bake Off information into a SQLite database. So you'll find it on in the GitHub page that GitHub link that I sent you. There should be a Great British Bake-Off.db. And you will see that SQLite database is something you can use to practice on, okay? So there should be 2 tables in there. I can't remember if there's more than that. I did it quite a long time ago. But the main one that we're concerned with is Baker results and results, right? So for this one, we can see in the Baker results table, here, what it's doing again is saying, now just assume we've created this connection previously, right? So now you've seen, we would have said connection, db connect to an RSQLite using the RSQLite package. I want to connect to the Great British Bake-Off.db. Okay, we've settled on our connection. Now it says, okay, reach into that connection and get me everything in Baker results. So all this is doing is saying, select star from Baker results. Now we qualify it using dplyr. So we're saying, okay, that thing said select star, but now I want to select series, Baker, star Baker to technical top 3. So what this does is very nicely, we don't have to list everything here as well. We can just use normal dplyr syntax to get us what we want. And this is, even the SQL equivalent would be select series, comma Baker, comma star Baker, and then everything else that's in between to top 3, right? So it'll be comma technical winner, comma technical top 3. So we can save a little code writing here. And then this head 3 is the same as saying limit 3 on your SQL query. And again, you can see it's giving you this question mark, because it's saying, I'm only giving you a snippet of the data. Here, technically, though, it's giving you everything because we've asked it to limit it to 3 records of these particular columns. Okay, here, what is this data set? Basically, what it does is it has all of the different series of the Great British Bake-Off with every baker that was involved in that series. So it will list you all the bakers that were a part of that series. The results table is similar. We say, select everything from results. I want to then filter or select just a few of the columns. I'm just interested in series, baker, result. I'm also then only interested in the results where the person was a winner. So here, what I'm doing is I'm saying, go look in results, but now I only care about the winners of each series. So series 1, you can see was won by Ed, series 2 by Joanne, series 3 by John. Again, this head 3 is limiting your query. Okay. So here's another question. So remember, there's a SQLite database that we're using. Which code A, B, or C will actually make that connection for us? If you know that it's a SQLite database in your working directory. Again, can I have a panelist volunteer?
I'll go again. Yeah, I'm going to go with B.
With B. Okay, so I think that's a good guess, Kevin. The only thing is that, so this is needed. Your user, password, DB name is needed for a lot of your other databases. For example, your MySQL database, your Postgres database, your Redshift database. A lot of them do need like a username and a password.
Yeah.
Unfortunately for RSQLite, because it's the SQLite database dialect, it doesn't actually have all of that. No username, no password, and things like that.
Yeah. Okay. Yeah.
So yes, yeah.
Yeah.
But thank you for
That was
trying.
my hunch there, because B would be very similar to what I would use for something else. Yeah.
Yes.
Okay.
Yes, you definitely use this, and arguably SQLite is, we're just using it now for kind of the workshop purposes, and you'd use it for learning purposes, but you wouldn't usually use it for a lot of even your analysis work.
Okay, yeah.
I think it's just more for that, for playing around with these packages rather than for heavy lifting. Heavy lifting you would do in an actual, you'd connect to a Postgres database, so you'd connect to a MySQL database, and then definitely you'd have to use a proper package, and you'd have to tell it where's the host, what's my username, what's my password, what database am I actually connecting to.
Okay.
Cool, thank you. Okay, so then there's this exercise 1.rmd that's in the GitHub repo. So we can work on it together. But maybe let's finish the presentation, and then we'll jump over to that, right? Okay, so most of this is just from the slides and how to present. I used Dr. Alison Hill's teaching and production. I used the Sharingan package to make the slides, and I used a lot of Mine's her tutorials and things to put this together. For more resources, databases using R, this is very useful. Like nearly everything that I've learned is from that page. It's like a book with a lot of resources in it. I'm going to switch over there. Just tell me if you are able to see it, panelists, please. Here, this database is using R, so it's db.rstudio.com, and you'll see it's a link on the slide. You can easily get there. It has all of the information that you would need. It's very full of like examples, what databases are actually supported, where they actually have an R package that you can use versus where you need to use an odbc driver. So there's a lot of useful information on here. Then dplyr backend, the dbplyr package. Also here, we've got, I hope this one is a bit clear as well. So dbplyr, if you want to know anything about dbplyr, you can use this page. But basically, it's all the dplyr verbs that you can use to connect to your database. And it will convert your dplyr code to the SQL dialect. I've also got quite a few different tutorials for databases on my blog. So what we're doing currently is going through part 1, and there's some parts of part 2 and part 3 that I have on the RMD file that we will go through later. And then there's also using SQL and R Markdown. So you can have a look at that. I'm just going to stop the share because it's hiding my slides again. Okay, if you want other examples to try and to practice with, I have a package called Recluse, which is also on my GitHub, which contains a database that mimics the SQL murder mystery done by Northwestern Knights Lab. So that one can also be helpful for if you want to learn dbplyr, or if you want to learn even SQL. And then I've also I don't think I've done this. I will push these scripts so that you can make your own Postgres version of the Great British Bake Off. But I have included in the GitHub repository some of the notebooks to make like the Star Wars database in MySQL, as well as a few extra resources as well. Okay, so thank you. That's the end of my presentation. We'll jump into the code version now. The blog URL, that's my blog URL. I just popped it in the chat. So let us jump in. Okay, I don't know if anyone has any other questions from the presentation. Everyone good? Okay, let's continue. So this exercise was just meant to help you reinforce what we've just learned, right? So again, I'm gonna ask the panelists to maybe help me out, because we're gonna run through this code. You'll see that it has like a couple of blank spaces that we were meant to fill in. Like here, etc., right? So please, panelists, if you can jump in, it'll make it a bit more interactive and not just me talking to myself. Cool, let's run this. Okay, so we need the DBI package, Tidyverse, and dbplyr. Okay, now to make a connection, right? It's gonna be, we're using something that's in our, oh, I also hope everyone can see clearly the screen.
Yes.
Cool. Okay, so we've got a couple of DBs in here, right? There's the Great British Bake Off DB. So if we want to make a connection here, and we know it's an RSQLite database, do you know what should go here? Come guys, don't be shy.
SQLite, is it?
Yes. Thanks, Kevin. But Kevin's the only one who's willing to...
Yeah. I'll be quiet
actually,
next time.
I tried to put mine in the chat.
Oh, did you put yours in the chat? Sorry, I can't see the chat anymore. Yes, cool. Okay. Cool, so no errors. Hopefully we've made a connection fine. Okay, so we can also check. So we can say db list tables. And then I want to list the tables on my connection, right? And this is going to give me what's actually there. Oops, what did it do? That's not right. Cool, so we have quite a few different tables on here. You can see the baker's results one and the results one was the ones we talked about in the slides, but there's other ones in here that you can also explore. Okay, so one of the things is now, okay, let's say we're interested in seeing how the actual winning bakers performed across the season that they won in, right? So like how many times did they win Star Baker and how many times were they top of the technical charts, right? So to do this, we'll use the same ones that were in the slides, the baker's results and the results table. Okay, so first let's get a list of the winners, right, of each season. And we saw that that was in the results table. So here again, it's saying select star from results. Okay, then I'm saying, okay, but I want to filter it out. So it's saying select, so from results, filter is where result is winner. And then it's select the series, baker, and result from that. Okay, but it's now this here, as we've talked about, all it's doing is querying that database. So it's going to give you a snippet of that information. Yes, it's storing that query here. So all it's doing is it's saving this query within this variable, but I'm actually not yet collecting this information. I haven't put a collect here, as you can see. Okay, and then we can have a look at the winners. And here again, you can see now in live code, this lazy query, where it's giving you back the snippet of information. But I do think there was like only 9 series in here. So we probably got all series in this result set. But it's giving you across all of the series who was the baker that won. Okay, now if we want to join 2 tables together, now I want to join the baker's results table. So you can see this table. Here it's giving you a glimpse of it. You can see it's telling you everyone who is in series A or 1, the name of the baker, the age, the occupation, and then there's a whole bunch more variables down here. We can also have a look at what the query is behind the scenes. So if I had to just run that part, you can see it's saying select star from baker's results. Okay, so now if I want to join this with the winners query that I have from here, what would I use? Anybody?
Do we want to use winners queue as the reference? That would be then right join, or we want baker result as the reference, then left join.
Cool. Yeah, we can use left, right, inner join. It all depends what you're looking for, right? In this case, because we kind of, so baker results, you saw had this huge amount of data, right? So if you were still interested in that huge amount of data, and then you just wanted to tag on the winners information so that you know for like series 1, who is the actual winner of the series, right? Then you would use a left join. If you wanted to just say, hey, give me everything from this data set, but I'm actually only interested in the winners, right? Then you would use an inner join. You'd say, go join these 2 data sets together by the baker and the series that they appeared in, just in case there was bakers with the same name across 2 different series. So we're saying, join these 2 tables by both these characteristics. And in this case, I'm only interested in that kind of subset of information. So I'm going to say inner join. But you can just as easily do a left join if that was what you're looking for, right? Okay, so that's the gist again. All it's done is kind of built up that query behind the scenes for you. So if we just look at the join queue, you see, okay, now it's joined the winner of the series. Like we saw, Ed was the series winner for 1 with all of Ed's information. So Ed's age, Ed's occupation, hometown, as well as all of his numbers for Star Baker. How many times did he win Star Baker? How many times was he technical winner? How many times was he technical top 3, etc. And again, we can show the query for that. This one's a bit more gnarly because you'd write SQL in a more concise manner than this. But here, it like uses like a subquery, for example. It still gets the job done. And a lot of people do work with subqueries. I think it's just your preference. But it's a nice way to learn SQL, I think. Okay, cool. So now we're kind of happy with the results that we've seen here. We've got our data like we wanted. So now it's time to bring it in, okay? So to bring it in, what we say is, okay, we want our join query. Then we're going to select a certain amount of information, right? We kind of want just the series. We want the baker up until result. So I don't know, pre-result I think is somewhere outside of here, right? We still want to filter for where the result is winner, okay? And we want to collect that information and bring it into R now, finally. Now you will have a winner's data in your environment that you can work with. So here you see, like for each series, it's the baker who won with all of their information comes through. Okay. Then some visualization. Okay, so let's say we were wondering, okay, how did the winner of series 1 do across all of the season or across their season, right? Now this is where the magic comes in. So we've done all of our processing on the database side. We made sure we're happy with the query results. And we said, okay, we're cool with this. Let's bring it into R now. We collected that data. Now it's sitting as a data frame within our environment. And now we can actually use it for further processing. So here is just one example of how you would use it, is if I want to plot this data, right? So this is some of the things that you do. You'd like during your analysis, you'd say, okay, now I'm interested in doing some exploration of this data after I'm happy with my initial database table exploration.
Vebash, so it's not a forced method to disconnect. You can always continue working without disconnecting.
You can, but here it was only because the disconnect is at the end.
Oh, okay.
Yeah, but you can do the disconnection as soon as you finish as well. You're very right. If you wanted to, you're done now. You've done all your processing, you've collected the data. You're not going to want to go back to the raw data any longer. You can do the disconnection right after you collect your information.
Okay.
Cool, but that was that exercise. Okay. Panelists as well, you must let me know if I'm going too long, because there's also some more information or some more practice on this workshop setup document as well. Okay, so just give me a heads up if it's getting a bit too much. So to answer the question, the DBI or the ODBC package doesn't bring the data into R until you collect it. So all the while while we're doing, let me go back to that file. So here, all of this information here is running on the database itself. It's not bringing anything into R. It's saying, go to the database and run this query, and then show the user a snippet of that data. Same thing for this one. Just says, go to the database, run the query there on the database using dbplyr plus the RSQLite package. It converts it to the dialect of RSQLite. Okay. All of this is happening on the database side. Database side. This is the only time when it does it on the database, but here it's saying, go bring me back everything. Now I'm asking you to run the query on the database and return me the result set. I hope that answers your question. That was from Temba. Yes, you can. So can we create or update any DB table using R code? You can. It'll probably also depend on what rights you have for the actual database. So on an RSQLite database, because there's no username, no password, no kind of role that you're connecting to that database with, you are unlimited in what you can do. So you can overwrite the table, you can append to the table, all of it is allowed, right? But if it's a MySQL database or it's a Postgres database that's kind of set up by your organization, there it'll depend on your actual role. Depending on your role, you can maybe create tables, but if you don't have that role permission, you won't be able to. I hope that answers your question. Okay, cool. Perfect. Pleasure. Okay. Okay, so this one, we're going to do a bit more practice, right? So these are some of the packages that we'll be using. I added one more here that wasn't on the list that Edson sent on the meeting invite. Just the R MariaDB, it's to connect to a MySQL database. Okay, so here we can go through this. Let me just pull it down. Okay. I think it may be easier to do it in here. I don't know what's your feeling. So you can't really, sorry, for the data, sending the data from R to the database without using an API. Sorry, excuse me. You can't do it except through the DBI package. Sorry, I think I'm not used to talking so much. Yeah, you can't actually do it without the connection. As long as you have the connection though, you can send it either via dplyr or dbplyr code or via SQL. You can actually send the query directly to the database. You don't need to do it through a dbplyr code, if that makes sense. We'll see an example as well in this workbook. Okay, cool. All right, so let's say now this is just extra practice, right? We want to create another RSQLite database in memory. And then we're gonna list, so this just goes through the slide information about the empty cars, okay? We're gonna create some tables. So what we're gonna do is, if you see an empty cars data set, it has like row names. So it has row names instead of this, the actual car name is not in a column, okay? So all this is doing is just getting that car name out because I want to have the full data set. I will then take the rest of it. I'm just joining it together. And here's the part that we're interested in, is at this connection that I've made to this RSQL database, I want to write this empty cars tibble to that empty cars table within that database. And I'm saying, look, it's okay to overwrite it, okay? Cool, so now that we've got it, again, these are some of the things we can do. We can list the tables. So we can see our empty cars is now there. We can go and see the fields within that table. So you can see car name that I've created is also there together with everything else. Here's, we can just run through this quickly because it's the same as on the slides. But this is just showing you the result of it. So here, lazy query, open the connection, select everything from empty cars, but then I'm only interested in filtering out the cylinder and I only want the distinct cylinder. But you can do much more than that. Like you can get, for example, you can do summarize on that particular empty cars information, right? So here we're gonna group by the cylinder. We're saying select everything from empty cars, group by the cylinder, but then I want to do some aggregations. So select the average displacement, select the average MPEG, select the median weight. You can also do other things as well. So here's the result set of that. You can do other things like, for example, let's say I wanted a new car name. It's a silly example, but if I wanted to paste the car name together with the cylinder, I can do that with a mutate. So mutate is allowed on that. And that is just saying, select new car name. So select this car name concatenated with cylinder as new car name. Okay. And then I'm only interested in you showing me those fields. We can show the query for that. So you can see it does this is what it's running on the database itself. So it's not your dplyr code, but this is what runs on the SQLite database. Okay, and here's the concatenation from that database. Okay, and if you wanted to see the result, you can say, hey, let me just have a look at that. It does a lazy query and it brings you back some of the information. We can collect that information if we'd like, and we can also do slice head. Slice head is the equivalent of limit. Okay, but here's the nice part of it as well, is that you can use SQL directly on that database as well. You don't only have to do it via dplyr code. So here we're saying, look, use this SQL code, and I want you to select from empty cars limit 10. I actually don't know how you run this. I'm going to try, but I don't know if it's going to work. No, it won't. So we'll have to see the results here. So this here is the same query, right? This here you notice is a SQL comment, not an R comment or R code comment, because the R code comment is with the hash. And here we're using the SQL comment, which is with the 2 dashes. So within this code block, it's saying, okay, open me up. I want to use SQL to query from the database. I want you to go through the same connection. It's the same connection that we've got here, that we still got live, that we're using. And it's saying, okay, now I want you to run this bit of SQL code on that connection. And this is the results. So it brings you back everything. But again, it's clever that it limits it to 10 records so that it doesn't flood you with information. Okay, the same thing for here. It's again, all we did was we took this, we dumped the SQL query that it created for us when we did show query into a SQL code block to see the results here. So here it's using actual SQL to connect to the database and extract information. And that's the result. And then once we're done, we disconnect. Now, if you try again db list tables on that connection, it should give you an error, or yep, tells you it's a closed connection. Okay, we don't have any questions. Cool. Okay, this I think if you have some time, maybe work through it. It's another example that's there for you, and this one shows you. It gives you a little more SQL code behind the scenes, or like dplyr code. So it shows you that more than what we've been working with so far is a lot of very easy queries, right? This shows you that there's a lot more that you can do with dbplyr, as well as SQL directly on your database before you bring it in for actual processing within your R Studio console. So I'm going to skip that one. I'd like to show you a MySQL database one, because there's it's in the DBI documentation. So in the DBI documentation, there is a little connection to this MariaDB database that's hosted externally. So it's not on my machine. It's hosted at this this URL, and here's the way that you can connect to it, right? Okay. So here we can see there's a lot more data that we can actually work with. And I wanted to show you this because this is now going to use the DBI package together with the dialect of the SQL database, which is MariaDB. So it's using this package which contains the drivers we need to connect via dplyr code to the database. And all of that is pretty seamless. Like, you still work with it the same way. it does all of the heavy lifting for you behind the scenes. Okay, so we're doing a couple of things here. We're gonna join, I'm not gonna go through the tables. I think it would be nice for you guys to also have a little bit of leeway to play with that later on. But it contains a bunch of like rental information for like a fictitious store. So they have film information, they have who is the actors in that film, what was the category of the film, what was the, how much is the rental fee, what stores were actually selling that or renting out that video, although renting of videos is a thing of the past. But this is a nice little database that I found that you can work with. So here what we're doing is joining a whole bunch of tables together. And then we're saying, okay, look, I'm only interested in these particular columns. And then I want to do some further processing because I'm interested in those columns, but then I want you to group me by the actor's first name, their actor's last name. This name is the name of the category. So it's just like action or fantasy or sci-fi. And I want you to tell me what's the mean duration of that particular genre that that actor has acted in. So like in all of the films that that actor has been in that genre, what was the actual length of that particular production? What was the average length of those types of movies? And what was the average replacement cost if you lose that video? And also how many of that particular genre did this actor act in? Okay. Okay, that all ran on the MySQL database that's sitting at that URL. So nothing in my R console. We can have a look. Like I don't have film category or film or any of those tables here. It's gone and done this, converted it to SQL meant for that MySQL database. And then it's run that on the database and brought me back the snippet of information. Okay, but I can also run SQL on it. The other nice thing about this is you can also run SQL on it and then collect that information into some output variable. So here I'm saying, okay, I've established that connection. Go use that connection. I want you to run this query on it, but I want you to take the results and put it in this ag MySQL variable because I'm going to use it further on. Okay, so this one I'm going to show you in here because I decided I want to try out Quarto and see what it's like, but I'm not sure how to run the SQL code on there. On R Markdown, you just press the button like normal, like any R code. Okay, just bear with me. Cool, so it runs this particular query and on the database, and then you can see the results of it now here. So I've collected this information. So I haven't, you'll see this is the query, but there's no results. Whereas previously, if I ran a MySQL query snippet, you saw the results below. Even though they limited it to 10, we actually could see the results, right? Here it gives me no results back because I specifically told it, go and put it in this output variable instead. Okay, then it's available for me to see. Now it is something that is in my environment. So here, I can't do it because it's not run here. But it would be in my environment that I can then utilize further on. This is what happens when you try new fancy things. Okay, so you'll have it to work with within your RMD file or your Quarto file. Okay, and then you can disconnect from that connection. Okay, then here in the tidyquery, so tidyquery is a different package, but I thought I wanted to show you guys as well, because what's nice about it is it allows you to work with the data frame as though it's a SQL database table. So you're allowed to run SQL on a data frame. And then you're also allowed to kind of get the opposite. So all along we're saying, okay, go make me this connection, do this dplyr processing, and then kind of show me that query result. And then I can kind of learn SQL even using that query result. This does the opposite. If you're more familiar with SQL, you can use this package to learn about the tidyverse. Because if you run, so here, this is still my, that MySQL output variable that I created from the SQL query that I did on that MySQL database, right? But now, if I want to then, based on that information, get maybe just the first name, surname, category, and here all I care about is the average duration, but I only want it for this person, for Adam, right? And I want to also order it by this mean duration descending. So I want to see anybody who has a name of Adam. For every category, I want to see what's the average duration, but I want you to order it by that duration descending. So it gives me back now this is on a data frame. So I'm querying a data frame as though it's a SQL database table. That's quite cool. So then it gives me back this little table of information, but I can also run that same thing into this function called show dplyr. And that one gives me the SQL, the dplyr code. So you can learn tidyverse using this. So it shows that, okay, what I've done is I've taken this table, I run a filter on it first, but my filter is using the string R, string to lower, because I'm looking for lowercase Adam. It then mutates stuff, so it renames things, name as first name, surname as last name, category as category, and then average duration, the mean duration as average duration. Then I also want to arrange it by descending mean duration, and eventually these are the few columns that I'd like from it. So that's quite nifty. Okay, there's one other thing I'd like to show you guys, because now we've worked with this MariaDB, but it was on the web, right? There is also a way within your R Studio to actually work with the MySQL database. And mine is set up already, and I have a blog post about it, which you can read further if you want more information, you want to try it out yourself. Because that process is very long to try and make the database and create it and install MySQL, etc. is long. So I'll just show you the connections. Just want to make sure it's disconnected. Yes. So I have this connection. So if you go to your connections tab within R Studio, any connection you have made previously will show up there. So this is my connection to my local database that I have on my PC. It's the Star Wars database that I created. And with my, what must I connect with the admin user? And this is my password to get into it, okay? I can easily go here and say, I would like to connect this via the R console or via an new R script or notebook, or just copy it to the clipboard and paste it in a Quarto document or an RMD file. I'm going to do it via the console because now what's really cool is it brings all of your tables in here. So this is everything from my MySQL database, but this is basically the one that I created. So now I can view this in R, like I can see what's in that table, just as though I'm viewing a data frame. Characters, films, etc. This is really cool. So it would be the way that you would connect to a database that you have for your organization, and you're still interested in using R Studio to actually do most of your work and your processing in, you would do it this way. Okay, cool. That's pretty much all from me. Don't know if there's any more questions. Everyone's still awake.
I don't see any questions. So let's see now. Let's check where Edson is. I think Edson dropped off there with internet connections.
Looks like there is no question.
Okay.
Yeah, thank you very much, Vebash. You are so grateful.
No, thanks for the invite. I was glad to be here. I hope it was helpful.
Yes, it was. We have to learn a lot. We have to sit down and try to understand it more. Thanks. Yeah, we are done, guys.
There's a note of thanks there from Sainte-Marie Vivier. Awesome, thanks for the cool presentation.
Cool, thanks, Anne-Marie.
Yeah. Right, I'll stop the recording. Sorry.